it?
We're live.
All right. Welcome to another edition of Point to Point. Today, we're going to talk a bit about biasing. There's going to be two little segments here. One is the nuts and bolts of biasing your Carr amp. There are three of our models that require biasing: the Slant 6, the Mercury, and the Raleigh. And then in a second little bit, I'll talk about what bias is, why it's important to us. All right. So we've tried to make biasing very easy for folks with our amps. I'm just going to grab this as a pointer. And something Mike Kinlan on the camera. You just need a simple volt ohm meter. You could get a meter at Radio Shack for probably $10. This is a nice meter, a Fluke. You don't need anything this nice. The symbols are important to understand because there's been some confusion. This wavy line means AC volts, and this straight line with the dashes, that's DC. And this is DC millivolts. Those are the settings we're going to want. DC volts. And actually, we can look into this amp, if you would, Mike. This is the inside of a Raleigh, and here are the bias test points where you're going to connect, these probes. If you reverse them, it doesn't really matter. It'll read negative on the meter, but it's okay. So these can just be pushed up in here, and they will stay. You don't have to take it out of the cabinet. I'm just showing the innards and all. This is the bias pot, and so that's kind of the skeletal view. We'll do it for real now on these amps. So you would set your meter to DC millivolts if you had it. That's the best one. You could use DC volts too, and I'll say what each of them would be for these two different amps. We'll start with a Slant 6. I'm going to just set it to volts because that's probably going to be more common. You can see here the bias test points there. You set it to half power, fixed bias, plug in your probes, and then turn the amp on, which I already have. And then we'll set our meter set. So when I take it off standby, one other thing to point out on the Slant 6, let me tilt it forward. The bias adjustment pot is kind of forward up here, right in front. It's hard to see. Right in front of this choke, right in front of that transformer, you can feel the shaft of a pot sticking out. It's pretty easy to feel. So again, plug these in. Turn the amp on, and we're looking for 0.066. We've got 0.064. So I'm going to turn this bias pot. You'll notice it's changing. So I'm going to set it to 66. That's what we want. That's set to DC volts. If you set to millivolts, it's 1,000 less. So it reads 66. If your meter has that, that's the setting I would use, a little more accurate. Don't worry if this starts varying a little bit. The wall voltage is going to vary up and down. The amp, as it gets warmer, and it's going to vary the current draw a little bit. Approximately 66 is what the Slant 6 is interested in. And you can experiment sometimes a little bit. Take it down to 60, take it up to 70, just in that neighborhood, and see if you have a sound difference. We've done a lot of listening. 66 seems to be the best all-around tone for the Slant 6. All right, moving on to the Mercury. We had shipped all our Mercuries. Had to pull out my old one. This is my personal one that was one of the prototypes. You can see it's got handwritten stuff. One of the guys who used to work here, Forrest, every time I would remove a feature, he'd put a little smiley face somewhere, wherever that thing used to be. He always wanted me to simplify. So the Mercury has bias test points up right beside the power tube. This one's a little different because it's the prototype, but they're right beside the power tube. You can see they're the exact same little points as the other two you see. So kind of the same thing. You put the meter on DC millivolts, put the probes in, turn the amp on, let it warm up, take it off standby, and on a Slant 6 a Mercury, we're looking for 45 milliamps or millivolts. You're not going to adjust this This one's going all over the place. This tube has seen a lot of shows, so I try to get the most out of them. Approximately 45 is fine. See, if we set this to the DC volt, not millivolt, it's a lot more stable. That would be just fine. Don't worry too much about slight variation. Okay, so those are biased. I'll put it to 45 just to show that we do good work here. So anyway, I'm going to turn this off. One other thing I want to point out, this may be getting long, is how we measure this bias, what's going on. In the Raleigh, you can see these test points have a resistor that connects them. These come from the cathode of the power tube or tubes. It's a 1 ohm resistor. And really when you bias, you're interested in current, the current flowing through the tubes. There's, not to hit you with too much math, but this is Ohm's law. Voltage equals I, current, times resistance. This is a 1 ohm resistor, so it's 1 times the current. Pretty much gets the resistor out of the way. Now I have voltage equals current. And so that's why we set our meters to DC voltage or DC millivoltage. We're measuring the voltage across that resistor. That resistor is like a sensor for the current. And this is the safest way. There are other bias methods where you interrupt the path from the plate of the tube to the output transformer or some other method. Those that are dealing with the voltage inside the amp can be dangerous for the inexperienced person because it's the full 400 or more volts. But anyway, that's that's the end of this part of it. I think I'll do a separate bit where we go into the more technical parts. But thanks for watching. See you next time.